In example one, we're looking at a graph, the graph of y equals x squared, and we're focusing in at the point 1, 1, and we're trying to approximate what the slope is at that point. So if we look at Desmos and we type in our equation, y equals x squared, and we focus at the point 1, 1, they're asking us just to kind of figure out what the slope would be. Now, up to this point, we've always talked about slope in terms of a linear equation or a straight line. When we're looking at a curve, the slopes change. So the slope over here is negative. The slope at 0 here at the minimum is 0 because it'd just be a horizontal line. The slopes on this side are positive. So not only do they change, but they change sign. They go from negative to 0 to positive. And then also the slopes here are steeper than the slopes down here. So these would be larger numbers than the ones near 0. So the slope is continuously changing. But if we're focusing at 1, 1, we are just looking at this little part right here and asking what is the possible slope of this. A way to do it is to draw a tangent line through the point. So a tangent line is a line that will just cross the curve, intersect with the curve at one point. And so if you take a second to draw this on your paper and then try to draw a tangent line through that point. So I've created a tangent line that should work for the point. And if we look at this point or look at the line and use the line to evaluate the slope there. So let's zoom in a little bit. And we can see on the line, if we take one step to the right, so from 1 to 2, we're going from 1 to 3. So we take one step to the right and we're taking 2 steps up. So 1 box over, 2 boxes up. So that is a slope of 2 would be the approximation of the slope at 1, 1. So we've got a parabola with a tangent line, and our tangent line had a slope of 2. Example 2, we're approximating the slope of a graph. Graphically, this depicts the average daily temperature in degrees Fahrenheit for each month in Dallas, Texas. Approximate the slope of this graph at the indicated point and give a physical interpretation of the result. So they've given us a point and they want us to find the slope of it, but they also want a physical interpretation. So when we're looking at this graph, you want to look at the labels. So first of all, there's the title that tells you we're talking about average daily temperatures. The y-axis is measured in Fahrenheit, so we're talking about temperatures here, and it's starting at 40 and going to 90. And then here we're talking about the months, and we see that it goes to 12 because there's 12 months. We also see it starts at 0 just kind of as a starting point, but there's no value at 0 since we don't have a month 0. It's really starting at 1, which would be January in this case. So they're wanting to know what is the average temperature in the point that they give us, so in October. So the average temperature would be 68.65 degrees Fahrenheit in October in Texas. But they're giving us this tangent line and these dotted lines here, which is describing the change in the temperature. So what we see here is that from January to June, the temperatures are increasing. The average temperature increases, which makes sense because it's getting warmer. And then from about June to December, the temperatures are decreasing because we're going towards winter. And we see the drastic changes are happening over here and over here. So as we're warming up, it changes pretty drastically from January to about May. And then it changes really drastically from about August to December. But we're not seeing much change from May to August. The temperatures, once they're warm, they don't change that much, at least in Dallas, Texas, according to this graph. So let's look at what they say in the solution. It says from the graph, you can see that the tangent line at the point falls 20 units. So it's going down 20 units and for each 2 unit change in x. So as we go over 2, it goes down 20. And so we can estimate the slope. We know slope is change in y over change in x, or rise over run, and we're seeing that it's falling 20 degrees for at every 2 months at that point. So that means in October it's going to change 10 degrees that month, or the rate of decrease is negative 10 degrees per month when we're in October. So this means that you can expect the average daily temperature in November to be about 10 degrees lower than it was in October. So that is the physical interpretation, but what they're wanting us to do is make a tangent line and be able to identify the slope of a curve. And that's just showing you how it might be useful. We see in the previous page, they talk about a secant line and how you can turn it into a tangent line by introducing a limit as h approaches 0. And so we see the equation of the limit as h approaches 0 of f of x plus h minus f of x all divided by h. And we use this to find the slope of a tangent line. And so that's how we're going to find the slope of this function at negative 2, 4. The equation on the paper says a. We're often going to see that a written as an x value because that's really what a is. So we're going to take our function x squared and we're going to plug in this x value and we're going to see what the slope of the tangent line would be at that point on that curve. So we're going to start filling this in. I've got limit as h approaches 0. That's always going to be there. Now f is x squared. So this is saying take x squared and plug in x plus h. So we are plugging x plus h into the x squared function. So this is equivalent to that. Then we've got minus. So I have my minus sign in the middle. Then I've got the function, which is just x squared. So it's the function with x plugged in. So x plugged into x squared is x squared. And then all over h. H is just always going to be h on the bottom. So then you want to start simplifying. So here we've got the limit as h approaches 0. And I want to FOIL x plus h. So x times x is x squared. And then xh times, or xh plus another xh is going to be 2xh. And I've got h times h, which is h squared. So again, if you FOIL the top, that's what you should get. And now you're going to simplify. The x squareds cancel. So I've got 2xh plus h squared over h. Here we've got h's in common on the top, so we can factor out an h on top. So that would leave me with 2x plus h. And then here I've got an h on top and on bottom, which will cancel. And then the last thing you do is you plug in your limit. So we're evaluating the limit at 0. And so if we plug in 0, we're going to get 2x. And so this is how we find the slope. This would be the slope of the tangent line. And then we want to figure out what is the slope at negative 2. So now we just plug in negative 2 and we get negative 4 for the slope. In example 4, we've got the same type of problem. So let's write down our formula to find the slope of the tangent line. And looking at this equation, you know it's a line. So you already know the slope is going to be negative 2. So we already know the answer, but we're going to show our work and show how to get negative 2 using this process. So we've got limit as h approaches 0. F of x plus h means take the function, plug in x plus h. So that'd be negative 2 x plus h plus 4. negative 2x plus 4, I plugged in x plus h, and then minus f of x, so negative 2x plus 4, all over h. And then what we're going to do here is distribute and distribute so that we can collect like terms. So I've got limit as h approaches 0, and it's going to be negative 2x, negative 2h plus 4, plus 2x, and minus 4, all over h. And then we can cancel things. So I've got 2x minus 2x and 4 minus 4, and that leaves me with, I've got negative 2h over h. Now the h's cancel, and so you just get negative 2. Example 5, we're doing that same equation again. Because this will help us find the formula for the slope. This is the function we're talking about. And then once we have the formula for the slope, we'll look at the points that they're giving us. So what I've done is I've taken my function and I've put it into this formula. So I've got the limit as h approaches 0, f of x plus h. I plugged x plus h into the function. Then I've got the minus sign in the middle. Then I've got the function itself. And then I've got all over h. So what we're going to do here is FOIL this part that's squared, and we're going to need to distribute that. So that's our next step. We're going to have limit as h approaches 0. If I FOIL this, I'm going to have x squared, 2xh, and h squared. Then there's a plus 1, and I'm distributing the negative. And then we should be able to collect like terms. So I've got x squareds are canceling. I've got the 1s are canceling. And on top, I can take an h out of the top. So factor out an h, which frees up an h to cancel on the bottom. And so I'm left with the limit as h approaches 0 of 2x plus h. And so it's as simple as I can get it, and now it's time then to plug in the limits. So the h is going to 0, which means I'm just left with a 2x. So this is a formula for the slope. That's the formula for the slope. So now that we've answered the first part of the question, find the formula. Now it says, what is the slope at negative 1, 2, and 2, 5? So we're